Hello students. In the last class, I had analyzed how the line of base fit can be derived. The line of base fit most appropriately represents the relationship between two variables. One variable x, the other variable y. How change in x influences change in y. That particular relationship can be studied by different methods. 4 or 5 methods are there: maximum likelihood method, OLS method, GLS method, etc. etc. But the most popular method, widely used method, is the optimum least square method. Now that is called OLS method. Now today I shall show you how the OLS method can be applied. So till the last time we did not take resort to any type of mathematics, but for the derivation of for the applications of the OLS method, we have to incorporate various methods of differentiation, maximization, minimization, etc. Because as I had analyzed in the last class, to derive the line of base fit, the OLS method involves the minimizing the sums of the squares of the deviations. So minimizing the sum of the squares of the deviation implies we have to apply the differentiation method of minimization. So you see, again I am going back to the relationship between income and consumption. I am again going back to the relationship between x and y, income and consumption. I had assumed income to be y and consumption to be x, and we had the relationship written as x is equal to a plus b y plus e. This is the stochastic model of relationship between x and y, consumption and income. As you remember, A is autonomous consumption, B is marginal propensity to consume, and Q is the disturbance term, which assumes all the influences other than income which can influence consumption. Now we have to plot this, we have to represent this relationship by a straight line. We have to represent this relationship by a straight line. Because there are different scattered points. The points will be scattered. For one level of income, consumption is one type. For another level, consumption is another. For higher income level, consumptions are higher. For lower income levels, consumptions are lower. So different scatterness will be there, different types of deviations will be there, because human behavior are always erratic. There cannot be any uniformity in the behavior system of the individuals. Therefore, we have tried to apply the OLS method to show the relationship between x and y. We applied the data on x and y to derive the line of base fit. The line of base which mathematically or most appropriately represent the relationship between x and y. So we shall apply the OLS method. We shall apply the OLS method to derive the coefficients a and b. derive the coefficients A and B. We shall apply OLS method. And let us suppose that the OLS base fit equation, the line of base fit is designated as x cap is equal to A cap plus B cap y. So in this case there will not be any disturbance because this is the straight line. This is the straight line which you have derived from the different combinations of x and y, and which will most exactly, most appropriately show the relationship between conjunction and income x and y, and the coefficients derived are a cap and b cap. Why we have written a cap and b cap? Because we presume that we have already derived the points a cap and b cap. Now our next task will be to derive what are known as the OLS equations, because on the basis of the OLS equations we will be able to derive, only on the basis of OLS equations we will be able to derive the values of the numerical figures of a cap and b cap. Now the point is that what is EI therefore? What is E? Or you can write this I means if there are 10 combinations, I will be 10. If there are 20 combinations, I will be 20. If there are 15 combinations, I will be 50. Like this. So EI will be x minus x cap. Actually EI is nothing but it is analogous to actually U in the mathematical version. EI x minus x cap. So in this diagram, if this is the diagram, this is x, this is conjunction, this is income. So these are the values of x minus x. These are the values. This is one value, this is another value, this is positive, this is negative, like this. So what is EI? EI is x. You can write I here and x minus x cap, or it is equal to x minus x cap is this, so it will be a cap plus b cap y, or finally we get x minus a cap minus b cap y. Or if we give summation sign, this will be summation EI will be equal to summation this, summation of this, or summation of EI square is equal to summation of xi minus a cap minus b cap y of square. So this is the sum of the squares of the deviations. Summation EI square. Sum of the squares of the deviations. Sum of the squares of the deviations. This is most important. Now, what we have to do? We have to minimize this sum of the squares of the deviations. Here, mathematics enters the picture. The problem of minimization you shall have to apply. The problem of minimization. So, what are the coefficients? Coefficients with respect to which the function is to be minimized? The coefficients should be a and b. A and b. What is a? The intercept. So if this is the line, this is a, and this is the slope is b. The slope is b. So we have to minimize the sum of the squares of the equations with respect to a cap and with respect to b cap. So here we shall apply the mathematical problem of minimization. So this will involve if there is a function like this y equal to f of x, the condition for minimization are dy by dx 0 and b square y by dx square greater than 0. This is the condition for minimization. Now here you see the application of the first order condition. Here will involve, this is a case of, this will be an equation of two variables. So we shall have to apply partial differentiation here. This is simple differentiation. So in case of partial differentiation, instead of b, we use del. Instead of b, we use del. What is the difference between simple differentiation and partial differentiation? That is another matter that cannot be discussed in this particular class. So we have to minimize summation ei square with respect to a cap and put this equal to 0. And similarly ei square with respect to b cap and has to put this equal to 0. So this will be with respect to a, it will be twice summation xi minus a cap minus b cap y is equal to 0, or finally you shall get summation xi is equal to a cap na cap minus b cap summation y. And the second equation, from the second equation we shall get twice xi minus a cap minus b cap y whole square is equal to 0. Or finally we shall get into summation xi will be there, into summation xi will be 0. And finally we shall get summation xi square is equal to a cap summation y minus plus b cap summation y square. So this and this, these are the two OLS equations, on the basis of, by using which we shall derive the line of base fit. I shall explain in details in the next class, because this is very complex actually, and for the students who don't know mathematics, it will be quite an arduous task to grasp all these things. Thank you.